चलो कोई नहीं. Okay, so now we have the good understanding of data and databases. Okay, so we realize now that the data can get large. Like we're talking about the supply chain scenario. So supply chain scenario may we need the sales data, and we have the inventory data, we have the manufacturing data, we have the distribution data. We know how distribution is a pretty complicated thing. We have lots of distributors, and they can, there's a lots of plus and minus, and sometimes the data is not recorded on time. So the delivery has reached, okay, but it's not recorded on time in the database. It's recorded like maybe 24 hours later. So that's an error. That's a logical error, right? If I start analyzing the data and it is showing me 24 hours late entry, how will I know that it is late? I will assume that what you have given me is absolutely fine. Isn't that so? I will never be able to detect it unless the business guys tell me that this could also happen. Or if someone points out to me that, okay, I forgot to do this, this is late, this is a late entry. So then I will have to correct that error myself. Okay. So we see that we can record data in any corporate domain. We can record data for any corporate domain, automobiles and supply chain and banks and energy sector. Why? Why do you need to record the data? Why do we even need to store the data? What do you mean by analysis? Decision making, what's that? Yes, that's a good example, that if you have data about previous or you can say historical data about your operations, then you can forecast. But what exactly you forecast? Hey, let's try to discover a general term, like frequency of what? Huh? Stats? For example, in supply chain, what would you want to forecast? Sales or demand. You will want to forecast sales or demand. That's a good thing. What about the automobile sector? उसमें क्या forecast करना चाहेंगे automobile sector में? That's it. Sales. Yeah, predict the number of people who are going to buy, or predict the sales. There's a difference. Yeah, sales or forecast, predict or forecast, you can use interchangeably right now. What about the banking sector? What can you forecast there? Potential clients is, what about the numerical measure? The number of clients. Or you can evaluate the probability that whether this person is a potential client or not. So if some algorithm tells you that this client has an 81% chance of becoming a client, this prospect has an 80% chance of becoming a client in a marketing campaign, for example, then you can target that person through advertising or other things, or by sending emails. So that's one other thing, that you can rank your people on which you are doing marketing. You can rank them according to the probabilities which some algorithm will give you. Yeah. So let me just draw this. So let's say that in a marketing campaign, you are targeting 5 people, which obviously is a useless activity. You want to target at least 500. कि एक इलाके में जाएंगे 5 बंदों के लिए, ठीक है, but let's say we have these 5 people and there is some algorithm here which is from the data science or data science, machine learning are the same things. Just for definition for you guys is that they're exactly the same thing. Okay, so you can use them interchangeably. So there's this algorithm, machine learning algorithm, which can forecast the probability that this person is going to buy your product, again based on historical data. So it's like human beings. Like, for example, if you have never been to Sadar and the first time you take out your car and go there, you witness the roads that are always blocked. Then you go the second time on the same route, then you again witness those. After 3 or 4 times, you will definitely avoid going through that route. You learn कि नहीं यार यहाँ से नहीं जाने, तो हमेशा road jam होती है. So based on historical, we learn. Human beings are doing that. Okay, you are working in a company, you have a new employee, you talk with him 3 or 4 times, or you find him really not talkative. So the 5th time, you will not go to him. Okay? He does not want to talk. So based on historical data, human beings, we are learning every day. That's exactly what we do with the data. So one of the ways in which we can use the data is to make a forecast or prediction. Okay. So we are discussing the scenario that I have 5 people, but I don't know whom to talk because marketing is expensive. आपको पता ही है ना, marketing में आपके लाखों से millions of rupees लग जाते हैं. In a marketing campaign, you have to spend lots of money. So let's say in a marketing campaign, I have 5,000 people I want to target, and I have been given the money for that. But if some algorithm can tell me the top 50 people who are most likely to purchase my offering or service or whatever, so I can say, I don't want to go to 5,000 people. I can save like maybe 5 million rupees or 0.5 million rupees by just going to the top 50 people, or let's say top 100 people. And in those top 100 people, if your algorithm is even 50% accurate, you're still saving lots of money. Understand? So that's the power of prediction for the marketing guys. For the inventory level, the problem is very complicated because it is not easy to make a prediction about the inventory level, because like I told you, it is dependent on many factors, not just the sales. Yeah, sales itself you can forecast because sales has its own pattern only with respect to the customers. It is not dependent on the fact that manufacturing order, what was that, or what did the truck arrive on time, was the delivery signed, etc., etc. It depends on the customer's behavior and his wishes or whatever, and the external factors like whether it was a strike or something like that, or whether there was a promotion. Sales are dependent more on these things. But the inventory level is something which is complicated to predict because it is dependent on the sales, it is dependent on the deliveries, on the manufacturing, and it is also dependent on the external factors like the company policy or the government policy, the tax policy. So it's a horrible thing to predict. And if you can bring your inventory level to a 90% prediction level, you have done a big deal. In the inventory case, even 80% is a big achievement, or maybe you can say 85 is a big achievement. 85%. That means out of 100 times you are right 85% of the times. Your prediction is right 85 times out of 100. That's a very good result. But it's not easy to achieve. This thing is relatively easy. So we are now thinking of ways in which we can use the data, right? So we can make a prediction about the sales, and we can make a prediction about the which customers, as we talked about the clients, so we can rank the clients in this way. D. Yeah, that's Absolutely. And in the Wrangling course, that's exactly what we're going to be focusing on. We are not going to be focusing on the predictive part, but we are going to be focusing on getting, or you can say, juicing out, like जब आप एक lemon को squeeze कर देते हैं, we want to extract all possible information from the data, which can help me do predictions in a better way, or which can even absolve me from doing predictions, because they can give you some information on which you can base your business decisions. It's not necessary to do predictive analytics. Recently, I conducted a survey with one of my students regarding the state of enterprise machine learning in Pakistan. And the results were that, barring the financial sector, the applications are extremely limited. There's no application of predictive analytics or forecasting, as you call it. In the financial sector, yes, people are doing it. But in the other sectors, it's very limited. Even in retail, it's not much, because it's complicated, right? The results are good, but it's not easy to get them. But the wrangling part is not very difficult to do, and unfortunately, no one does it. Our tendency is to store the data and access the data and do machine learning, or just put that in a BI tool and do business intelligence through dashboards and charts. That's idiotic. I'm not calling anybody idiotic. The thought process is idiotic, because the data is talking with you. The data is telling you to wrangle me, to dredge me, to slash me. I can give you too much information, but we don't do it.
Sir,
Yeah.
so sorry for interruption. Nishat Ali is waiting for the meeting. Kindly allow him.
Oh, I'm sorry about that. Yeah.
Okay, thank you.
I can't see him. Acha, participants. Okay, so it's a good application. Similarly, the things that you forecast are primarily sales. The things that you forecast at the government level are economic indicators. You have inflation, GDP. So these forecasts are being done since the last 30, 40 years. And I'm pretty sure that Pakistan bhi kar raha hai. Okay. And I think the State Bank, etc. Yeah. So you can talk about the ARIMA models and all those things that you can make a forecast. It's not easy, because I have done the projects. In fact, I'll give you my YouTube channel. I'll just show that to you. So I have uploaded the projects of students who have done this nowcasting. Nowcasting means that forecast for the next minute or something like that. You mean, forecasting means the forecast for a longer time period, like the next week kya hone wala hai, ya next quarter mein kitni sales aayingi. Nowcasting means the forecast into the immediate future. So you want to nowcast the inflation rate and many other economic indicators. So it is not a very easy activity. Okay, so you can see the videos, you can download the code, and it's an interesting thing to see. Well, मैं अभी आऊंगा उसके पर. Everything we are going to discuss, आज हमें सारी वो करनी है, बेस बनानी है. So let's go back to this. Okay, so in the we're talking about this forecast. So primarily you forecast sales, and you can forecast the inventory levels. What about healthcare? You can forecast the number of patients. You forecast the number of surgeries. You can forecast the financial profit that the hospital is going to have. For the energy sector, you can forecast what? The consumption. So that you can better plan this load shedding, which it's not an easy thing to do, because you will have to do this forecast at each transformer, and there are thousands of transformers, I think, in Karachi. So how can you optimize? Okay, because the transformers are connected to stations, generation stations, and distribution units. So it's a very complicated game to forecast. But in this course, we have to realize that wrangling the data, wrangling means let's say that in simple terms, that you pick a stick and start beating, like you wash clothes in the old times. Even now, people who don't have washing machines, who are poor people, they wash the clothes through stick. You might have seen people who don't have houses, for example. So one should be thankful for what we have, automatic washing machines. But when you hit the cloth like that, so take that example of wrangling. Okay. Yeah, it involves many things. So cleaning is just one thing that you get out of that. Cleaning. So let's finish this slide first. So you can collect the data. Right now, data sources are innumerable. IoT is giving you data. Social network is giving you data, and you have the data for your own business. You can store the data. Primarily, we store that in databases. As far as big data is concerned, you store them in databases, but the nature of those databases is different from the relational databases that we use in the companies. In the companies, we use databases which store data in the form of tables. But for big data, mostly we use databases which don't use tables, but they are databases. Okay, so one of the example is MongoDB. It is a world-renowned database. Okay. Then we clean. What do you mean by cleaning? Remove the raw data. Remove the raw data. The data that you collect is always raw. Raw means as it is. So that carries for example, if I go to the e-commerce portal and do some stuff, it records one big row about what I did in that session, and it put that in a text file. It puts that in a text file and puts the text file on some server. There's raw data. Like we have raw meat. When you slay an animal or you kill a chicken, for example, to buy a chicken, so they slaughter the chicken, and then what happens is that you get the meat there, put that in a chopper, so that's the raw meat, and then you process it at home by cooking, etc. So the raw data is record as it is, as it comes. That is treasure for you. You have to store it. But why it is dirty? Sorry? Unwanted? Why unwanted? Okay, to solve a business problem, you might not need all the data. So in that respect, yes, some of the data is unwanted, but overall the data is not unwanted. Because if it is unwanted, I will not store it in the first place. I will use the data in somewhere, someplace. For that particular business problem, some of the data is not wanted. So yes, that is also part of cleaning. What else? Take minute ago. G. Correcting what? Sorry? एक second. Not correct. G. Duplication of data. Yes, we need to deduplicate. That is also one error, logical error you can say, or it's not an error, something that needs to be cleaned. Deduplicate and unwanted data, two things. Why would someone do that? So data entry error. So we can have the duplicated data. Some of the data might be unwanted. There might be data entry errors. And I think that's what we are referring to while you want to clean. So why? Why would it be corrupted? The data can get corrupted in transit. When you transfer data from one place to another place, for example, you record the data in some field, in agriculture field in Sindh, the data gets transferred from there to Karachi through some network. So in transit, the data can get lost. That's the normal behavior of data. The data can get lost in transit. So data is typically sent in packets, okay, or some, you can say, bundles of data are sent, batches of data. So one or more batch can get lost. It's possible. So in that case, yes, we will need to do something about that. If something does not complete, then that is corrupted. Half of the data comes, the half does not come. So yes, in that sense, some data might be corrupted. G. Sorry. Uh. Yeah, so inconsistent recording of some data, that is a big problem, that you have the same data in multiple formats. That's a horrendous problem to solve. I remember we were working on this project for a major hospital here in Karachi, and they had recorded the data of patient locations, and there was no format for recording, so it was just typing. So there were, like, if someone was writing Gulistane-e-Johar, so Gulistane-e-Johar was written in 30 different ways. So how can we clean it? It was, I think we took 2 to 3 months to just clean this column, this particular column. There were spelling mistakes, there were spaces, sometimes they were using hyphens, sometimes they were using spaces. Gulistane-e-Johar involves an E in between. Sometimes the E was there, sometimes it was not there, sometimes it was written small e, sometimes it was big E. We had dashes, we had spaces. Johor, the Johor word was written in 5 or 6 different ways. So if you record the data like this, how can we? Location is a very important parameter for an analysis. If you don't know the customer location, what can you do? So yes, there are thousands of ways, literally, not thousands of ways, or maybe you can say there are hundreds of ways in which the data can require cleaning. So that's also called noisy data. So you have data entry errors, you have missing values, you have corrupted data, you have duplicated data. That was a good observation. And I will agree with the fact that you don't have the data which you always want. Sometimes in the whole, like if you record the data for e-commerce activity, there will be lots of flags, unnecessary flags, which you are never going to use in your analysis. So you're going to have to do something about them. So cleaning the data is a huge activity which we will go through over multiple hands-on exercises. Okay. So when you I will give you the data sets which are dirty, and then you will develop your routines to clean them. You will understand the problems that are occurring in the industry. Okay. Transform is basically for after you have cleaned the data. There is one step also here which I think is missing, is to understand the data. So once the data is clean, so when the clothes are clean, then they are ready to be worn. Okay. But before that, you have to iron the clothes. Okay, to make them further ready for for varying. So this ironing can be taken like ironing gives shape to the clothes, right? Before ironing, the clothes is just a rumpled piece. It's nothing. I mean, you just throw it on the bed or any other place. But when you iron it, then you hang it up, so it gives shape to the data. Similarly, once the data is clean from all the dirty errors, you can say, then you can try to make sense of the data or shape from the data through descriptive statistics. And that is, you give it different names. You can call it EDA, exploratory data analysis. So you have to basically write these things down. Let me do this share. Yeah, so let me read the text. So there are multiple ways: data understanding, or you can say comprehension. Okay. You also call it EDA. Before data mining, this was what was called the data analysis. Even the BI tools came in 1990s. So before, in the 1990s and 1980s, and even now, there are many tools which just help you do the EDA. And we can also call it data mining. And in this you can categorize as the descriptive statistics, inferential statistics. So all of these things are there: EDA, data mining, data understanding. All of them are the same thing basically. And yeah, so the components of this can be, I'll just write them down separately. The components, I'll use a different color now. Oh, sorry about that. So so this is just go. I'll just take the other text box. So what are the potential things that can occur in the data understanding? We can do the descriptive statistics. We can do inferential statistics. We can do correlation analysis. And we can do regression. Just sort of, you can say, data mining side. We can do even clustering at this stage. Some statistical tools allow you to even cluster the data at this time. And there are other things. And what about the data cleaning activity? In the data cleaning activity, you can do lots of stuff. You need to fill up the missing values, which is a complicated thing to do. Okay. You have to deduplicate, obviously. To deduplicate, you have to identify. So identify and deduplicate. That's just one line of code in Python. Okay. This is also just one line of code, but there are different ways to fill up the missing values. You have to understand them. And then you can remove, cater for inconsistencies. Like we talked about the different formats for location and time. So it's a horrendous way of storing the data. Remove unnecessary data, which is not required to solve a problem. ठीक है? Every data is not required to solve a business. You can have multiple business problems. For example, what is the business problem in the car manufacturing industry or the car sales industry? What is the biggest big business problem? Sorry. Hmm. Okay, so the engine is damaging the environment. That's the biggest problem. So how can we solve that using the data? Electric. But I mean, this is not a database solution, right? This solution is not based on any data. What are the problems that can be solved through data? Okay, through the data, you can get the amount of damage being done. So if you have an idea of the emissions coming out of your cars, and you have an idea about the sales of the cars, then you know how much emission is going out depending on the usage of the car or some average statistics of car usage in a particular locality. So you know, okay, how much damage is being done to the environment, and you can use that data to present and and convince people to start the electrical. Yeah, that's good. What about insurance? Hmm. Hmm. Yeah, so these are very big problems that people are not typically interested in taking insurance. They have to be convinced again and again. And once they take the insurance, they are not paying their premiums on time. That's also a big problem. And they can drop off anytime they want. So yeah, that's a big problem. So the data analysis in your case is extremely important. And you can divide data into different customer segments. Okay, and those segments can then be analyzed separately. That's where clustering comes in. Now, I can do clustering as part of machine learning as well. Any machine learning comes after the wrangling stage. Any forecast or time series predictions always comes later on. But when in the clustering, I can use that during the wrangling part as well. So you can form clusters of your data to understand the data in a better way. Your the marketing people need the customer segments. So in my opinion, customer segmentation is an activity which should be done at the wrangling stage. And it could be anything. I mean, based on any customer data that you have. Typically, we form the segments of the customer. We don't take the customers as one block. Why? Because the customers have different behavior tendencies. Similarly, like the state bank can form clusters of different banks according to how they are behaving homogeneously. So you can see if 5 or 6 banks have the same type of policies for running the banks, you can put them in one cluster and deal with them in one way, rather than taking each bank separately, which just adds to your workload. Similarly, we have thousands of customers. So if we group the customers into 3 or 4 groups, it becomes easier to manage them. And it's always possible because whenever we do clustering, we do realize that we can do that in a good way. So form the clusters of people that or any other activity that you deem feasible. So for example, if you are manufacturing tea, चाय के अगर आप बनाते हैं तो tea comes in many different flavors and sizes and boxes. Okay, so if you start taking each product separately, then it's going to take a lot of time. You can't analyze. But if you form the clusters of these offerings, like maybe you have 25 different offerings of tea. Some are tea bags, some are plastic bags, some are boxes, some are bottles, some are 1 kg, 2 kg, 500 grams. There are so many different offerings of tea. So what if I group all these into 3 groups according to their sales and according to how they are bought? So I can detect 3 different customer types of customers who are buying my tea products. Rather than I take each tea product separately and analyze that, it's going to take a lot of time because I have to develop a unique strategy for selling tea. I can't develop a strategy for 25 different brands of tea. I have to develop one unique strategy for selling the tea brand that I am manufacturing. So, समझ में आ रही बात की? So in this respect, clustering becomes very important. So my understanding or recommendation is to spend at least 70% of your time on data wrangling. Machine learning becomes a piece of cake later on if you are doing the wrangling properly. So, G. And wrangling is a more general term which involves cleaning. Cleaning is just one activity that we are doing. I mean, so here all of this is cleaning, inconsistencies, deduplication, filling up the missing values, and you can also add here removing data entry errors. That's the real cleaning. Data entry errors, like Binish said, that someone can put a string in a numerical column, that is possible. Okay, so especially if you are translating data from forms to the database. So users filled out a form or something like that, and you transfer the data from the handwritten form to the so someone who does that can make a data entry error. Yeah, exactly. You can easily make a mistake on typing or something like that. That's quite common, in fact. And in fact, in Pakistan, the biggest problem is data quality. All of this is data quality management. Wrangling is the name of the course, but it should be data quality management. If you look at if you do a Google search, you will see that data quality is a problem which is being faced by almost all the organizations. Our tendency is to make a forecast or a prediction. In fact, there is no there is no uh, there is no use of doing a prediction unless your data is clean. Yeah, it's useless to do it. Your predictions are going to be inaccurate. And if you have understood your data very thoroughly in wrangling, maybe you don't even need to do prediction. That is also possible. Pakistan data quality practices are not very good. Horrible even in big companies. The big companies are likely to maintain more than one database. Why? Because the data is not being managed properly. As simple as that. There is no mechanism for developing schemas. Or schema means the shape of the table. Okay, schema means columns kya honge. That's the schema. What will be the name of the table and what will be the name of the column? That's called a schema. So the schema, when you create the database, the schema is pretty simple. But as the time moves on, you need to modify your previous tables. You need to add more tables. So the schema keeps on changing. Database keeps on evolving. Understand? And there is no policy. How do you develop the database? बस जो ज़हन में आया वो कर लिया. इस वक्त मेरी अकल जो चल रही है उसकी में ये बात आ रही है तो इसके मुताबिक मैं स्कीमा बना देता हूँ. That is not the way to design a database. You need to have a policy for doing anything. You need to have a policy for doing all of these things. Descriptive stats, inferential stats, how do you cater for missing values? Those policies are provided by data governance. And data governance is something which happens at the top of the organization, and all the CIOs are involved in that. C-level executives, all of them are involved. The CIOs are COO, CEO, COE, CDO, whatever we have. All of them are part of the data governance council. And they form a policy for anything that you do with the data. There must be a policy for that.
Sir, I have a question.
Excellent. Ji, bole?
Sir, I have a question. The question is that if we have a big data and after doing the data wrangling, how we be a to know a possible that our data is now in a position to be analyzed. So
we have several standard practices that have been written down in several books and across thousands of websites, and according to our own experience. We need to follow all these standard practices, and the practices that I've written on the whiteboard, they are according to my own experience. But I think it sums up everything that we need to do with the data to get information out of that. So when you see the output of Wrangling document that you guys are going to create, inshallah, at the end of this course, you will yourself realize that you are ready for machine learning.
Okay.
That's the thing. Okay, you will say, okay, we know the ins and outs of data. That's we know what this data is telling us. We know how to use it now. So you get comfortable with the data. That's the thing. G, you're asking something? Pakistan does not have any data governance body. Maybe if the IT ministry has an inclination towards that, then they are going to launch several products and they are going to create centers who are going to implement that. But I think the biggest need of the moment right now is data governance, because data quality can only be controlled through governance. And I'm telling you that there are companies in Pakistan who are maintaining multiple databases because they are not able to manage the schema creation, data updates properly. Big data is one of the main problems, that we have multiple databases because the data is increasing all the time. And the data is just there. The purpose of BDA is to ensure that all the data gets used for analytics. And that is definitely not happening. Maybe 30% to 35 or 40% of the data is being used. There's a lot of data which is just there in your database. You never use it. Sometimes you run the SQL over it. Sometimes you create some charts, but it is not used aggressively. Yeah, company wise, but they need a lot of guidance. Some of you maybe can create some software house for providing consultancies in this regard. They need help. Okay. So transformation is done when you have cleaned the data, you have analyzed the data, wrangled it, and then you want to do machine learning. So for that, you need to do some transformation. So that's not the topic for our case. We typically do some transformation, but we do those for cleaning. So that is not transformation for machine learning. So for example, I can transform numerical values to string values just because we can't have numerical values. So that's not transformation, that's cleaning. Transformation is something else. That, for example, I change the range of numerical values. I have age and let's say I have sales, or maybe I have, let's say, let's say I have the age of the customers in the range 24 to 38. And I map them to string values. So I can say 24 to 30 is an adult, or 24 to 40 is an adult, 40 to 50 is senior, and 50 to 65 is, I don't know, most senior, and above 65 is old or something like that. So I can create these discretizations. If we have numerical columns in which data is occurring in some range, for example, some data is coming from a sensor in the range of 1 to 100. So I want to map it in the range of 0 to 10. So I can do that mapping. So that's a transformation that you want for machine learning. So we can analyze the data. We can, data security is something which is the job of the IT department typically. And for this, we have things like encryption mechanisms. We have data security, cyber security practices. So these days, it's a very hot topic. Like you have all the things being done on mobile. So the security is being compromised. Like we have WhatsApp and all those things, so much things going around. देखिए banks का देखिए if you have clever people, they can hack into your data center. I think they're more secure on the cloud because there are, I think, hundreds of banks who already have their data on the cloud. So yeah, so it's you need to sign an SLA. I have still to hear of a data theft on the cloud, major data theft on the cloud. Still to hear about it. I just read one case like several years ago of Amazon, but it was not given any. It was fire, but it was not given any wind. It did not spread. So I think for cloud is going to solve many of your problems of data quality and other things. Checkbook culture is okay. It provides security as well. But I'm talking about analyzing the bank's data. So in the data center, you need to be more open about it. But if you don't want to go to the cloud, then you implement things in your data center. But our problem is to analyze the data, big data. Now HBL is creating a data lake. And data lake is the newest repository for doing data analytics. All of the raw data does go into your databases, but basically it is part of the lake. So a lake is, it's not the scope of this course. Maybe we'll discuss that somewhere down the line. It's a repository of data. The latest trend is to show your data in a data lake if you want to analyze that. It does not consist of clean data. It's the raw data which just falls down into the lake. You store the data in the lake again in databases, but the databases are part of the lake. The lake has a specific architecture to guide the flow of the data towards analytics. The lake has a specific methodology to follow. So it's more controlled environment as compared to the fact that you have databases and you don't have control over them. So typically our IT departments are facing this issue. They don't have data quality practices. And therefore, if someone wants to do a BI project or a machine learning project, the first thing they face is the data quality problem. The data is dirty. The IT people do not have the time to help the data scientists because the requirements of the data scientists are not the IT requirements. IT requirements they are busy in their own requirements. So the data scientist has to do everything himself or herself. Yeah, ERP systems are a bit more well managed. Yeah, I will say that, but they don't have the data understanding component. You have to do that yourself. Even the cleaning is not there. They are just storing your data so that it becomes easy to collaborate. They are not cleaning the data unless there are functionalities for cleaning the data, but you have to configure them. But our recommendation is to develop your own pipeline on Python. SAP and these solutions are not going to help you do the data quality as you want it to happen. I'm 100% sure about this. They can help you collaborate between the departments. They can help, जैसे Microsoft का 365. What does that do? It helps you collaborate. That's all it does. It is not cleaning your documents for you, right? You can write whatever you want. It's not going to clean them. It can tell you कि ये error है, but you have to remove it yourself. जैसे word का वो auto correct वगैरह होता है, तो I mean, no software is going to do the cleaning for you. Because why? Tell me. I can have an automatic software which automatically cleans my data, but why is not that a good thing? Yes, the software does not know what problem I have to solve, and the data is specific to each problem. Let's say I want to solve the problem of inventory management. For that, I need data from 3 tables, and I have 20 tables with me. So which 3 tables you want? And on 3 tables में कौन-कौन से problems and the software does not know. So you need a human mind to clean the data. You can't automate everything. So for example, if you want to fill up the missing values for age का data missing है, let's say 50 customers में age का data नहीं है. You don't have age data for 50 customers. How will you fill those values up? Average. What if the average is 48? If the average customer age is 48, so how can we assume that those 50 customers have an age of 48 or a bracket of 40 to 50? How can we assume that? Why repeat? एक दफा बात होगी, बस एक दफा सुनेंगे. क्वेश्चन ये है कि अगर आपके पास कस्टमर्स का डेटा है जिसमें एज आपने रिकॉर्ड की है and 50 people have not specified their age, how will you figure out? Because you have to use the age data in any customer analysis problem. So you want to fill up those values. I can't say delete those 50 rows क्योंकि age का data नहीं है. हाँ, मोड यूज कर सकते हैं. स्टैटिस्टिकल टेस्टिंग कहां से हो गई? मैं तो आपसे पूछ रहा हूं, आई एम जस्ट आस्किंग यू टू थिंक के so let's say ke this is the data, this is the age column. Okay, I have data for 10,000 customers with me, so I have 10,000. क्या सही? 10,000 customers में मेरे पास इस टेबल में 10,000 क्या होंगी? Rows 10,000 होंगी, right? So I have 10,000 rows, but for the first 50 rows, from the first row, आमतौर पे numbering हम 0 से start करेंगे, ठीक है? So 0 to 49, the first 50 rows, this is not there. बाकी ये data आपके पास सारा है. This is there. I don't. One thing is to delete all these 50 rows. Okay, ठीक है, data नहीं है, just delete them. What is the disadvantage? Loss of important data of the other attributes that are there. उसकी sales है, उसका gender information है, उसकी we got recency, we got so many things. It will be lost. How can you delete? How you don't delete the sales data, right? So how will we fill up these values? Through these rows, mathematical model. What is that? So your name, sorry? Vakas has given a good idea that Vakas is saying that we use this data to build some sort of a mathematical model. Obviously, we are going to be using this information as well because the rows are the whole row will be used, right? We don't use one single say. So use all of this data to build a mathematical model and use that model to predict the values of this 50 rows. That seems to be a good idea. Yeah, an early algorithm, like this is typically a regression problem. in which you want to forecast or predict numerical values. So I think that's a good idea that you fit the model, but that seems to be a bit complicated. Anything simpler? Banish told us that we can take the mean. So let's say the mean of the data is, oh, sorry, 48. Average age is 48. Then I put 48 for these 50 rows. How can I assume that all these 50 customers have an age of 48? That's a big assumption that you could destroy your analysis. I can't make an assumption like that. It is we are naturally thinking that the mean is a good solution. In fact, the mean is absolutely not the good solution. Kapil, I think, is making coffee. Yeah. So mean is not a good solution for filling up the missing values. Never. It's never a good solution. Okay. That's the best thing that you can hear for solving this problem. Analyze the data, which is also what you are, but you are saying we do that mathematically. She's saying that we do that using Wrangling. So Wrangling can tell us, okay, look at these rows. What is happening here? Okay. Try to find out the data similar to this in this part. Understand? And let's say I find out this data, which is similar to the data above. So look at their ages. Now you can take the average of this part and put it there. That makes sense. But you can't take the average of all the column because that's going to be a huge assumption. And what if I am losing the data for 250 customers? In the insurance domain, it's very common to have hundreds of customers who have not given their ages. How can you fill that up using mean? You have to analyze the data for the other attributes, see the similarity of that with respect to the data which is available, and then use the age information of those rows to fill up the missing values. Okay. There is also one other thing that, let's say I plot the data for age with respect to time. The timestamp is always there. So I sort the data with respect to timestamp, which is naturally sorted. My age, let's say, is varying like this. Here I have a break, the missing values. Okay. And then I do this. So after that, we will take the break. Okay. So this part is missing. These are the 50 values which are missing, let's say. So now your solution was this. Okay. So what I will do that I will try to fit a mathematical model over this data. So obviously the model is going to give me something for this break because I just have to plug in the values of the time and it's going to give me the data. And so I filled the submodel and I use the values of the model to fill up the missing values. So yes, that's also a solution which Waqas has told. Banish solution I have already explained to you. There's one other solution that you look at the values which are like, in this case, I don't have to fit the model everywhere. Okay. I look at this is the part which is missing. I look at what is happening here in the near recent past, very near to what happened just 2 or 3 timestamps ago, and use that value. Uska average nikalne, that will be something. Okay. Take the last 10 rows, take the average of that because there is always a pattern with respect to time. In any data that you have, numerical data, you can almost always detect a pattern with respect to time. So for example, you will say that, give me an example. So in e-commerce, the school or university students are expected to come at a certain time. They can't come during the day because they have classes or they are sleeping, unfortunately. Okay. Old people are likely to come early morning. सुबह उठेंगे, नमाज पढ़ेंगे और इंटरनेट पे बैठ जाएंगे browse करने के लिए because they have all the time. In the afternoon, they can take a nap, for example. So yes, there is a pattern of age with respect to time. Okay. So if I have that time, I can just look at what is happening nearby, like रात के 10 बजे का data missing है, I can assume कि age बच्चों की ही होगी. So it will be safe assumption. So in this way, imagine the fact कि एक variable के ऊपर हमने आधा घंटा बात की है, still the problem is not solved. So wrangling is not easy because of the fact that you have to make assumptions, which might get wrong, and you have multiple ways to solve the problem. So therefore, you need to have a policy. इस तरह नहीं होगा कि I give you the data and every time you do wrangling and every time you develop your own policy. That's a very rowdy way of doing things. So let's finish this slide and then you can take the break. So yeah, secure, govern, share. I want to share the data. I want to govern the data, analyze, secure. You can think of other things as well. Ingesting basically means getting the data. So in Python, we can ingest the data. In any tool, Power BI, etc., you can ingest that. Ingest means to get the data. So the databases se data ingest karne ke liye, you need to have connectors. So typically Python and all these different programming languages are giving you connectors for connecting to the database, and you can get. I have a MongoDB connector. I have an Oracle connector, JDBC, ODBC connectors for getting the data from the database. So any data source you have a connector for that. And ingestion means to use the connector to get the data. And ingestion itself is a huge activity. How much data you need to collect, with what velocity you're going to get the data. Okay, where are you going to store the data? After which interval you're going to get the data? Are you going to be running it 24/7 or not? Which software you're going to use to do the ingestion? So there are lots and lots of questions to be answered there in ingestion. But I think ingestion is typically being handled by the RT guys, so you don't need to worry. The data is falling into the database. So wrangling is to do all the above to make it ready for analysis. We're going to be focusing on data cleaning and data understanding. So that is all 10 to 15 different activities that you have to go through in this course. Okay. So you can, I'll just pause the recording. Okay. Ji. Yeah. It's a very good question by Ghulam Kamar. Yeah. So the question is that if the data is coming in real time, like coming from IoT sensors, for example, or coming for stock prices in real time, we don't have the time to wrangle because we want to make a prediction in real time. I want to forecast the stock, let's say in real time. Stock values they don't have very complicated data in the first place. It's just a timestamp and the value. There's just two columns, right? Okay, we have a timestamp, so there are hardly any missing values, and there's no need to wrangle the data in real time. You wrangle the data when you have multiple columns and you have thousands of rows, and each column gives you a separate problem regarding data entries and duplications and many other things. Stock market data is happening in real time, and it could have more than one column. I'm not saying that there's just two columns, but primarily we just have one time column and the other KPI that you want to forecast. So we have multiple time series that we want to forecast, right? So we have multiple problems, but there are no data entry issues there, because typically you are getting the data live from some reliable data source. So stock data, oil prices, and data like that are typically very reliable. There are no data entry errors. Yes, but your interest will not be with 450 companies. Your interest will be only with some specific 2 to 3 companies. But you will not want to forecast for 100 companies at the same time. Like, for example, you want to forecast the oil prices. So oil prices can have 2 to 3 different time series of oil prices that you want to forecast. Why would we want to, if you want to make a forecast for each company separately? So in that case, you have to start small. You can't start forecasting for 100 companies at the same time. You have to figure out your competitors. What are the top 5 competitors I have? Or what are the top most 5 reliable companies that I trust the most? So forecast for them. But forecasting for 100 at the same time is not a business initiative. It's too much. You can't, I mean, what will you do? How can you analyze 100 forecasts? So the problem is that in real time, with this type of data, wrangling is not needed. And you don't forecast in real time. Like, even if you want to nowcast, you take the data for maybe 1 month or 2 months. So that's quite a lot of data. If the data is being generated per hour, so data for 2 months is quite a lot of data, several thousands of rows. And then you can start forecasting for the next hour. So in fact, that is even better because you can't make the model in 10 minutes or even in 60 minutes. So you will have the data coming all the time. So for example, you took the data till 3 o'clock today, but by 4 o'clock, you will take 3 days to design the model, maybe 1 month. So 1 month data is still being accumulated. That can be your test data. Because when your model is ready, you will start forecasting from 4 p.m. and the 4 p.m. data is already there, so you can compare. So that is good. So it does not mean that I'm doing the modeling at runtime. It takes time to build up the model. It might take 3 weeks to build up a good model if you are a good data scientist. Otherwise, it might take even 1 month to build a good model because you need to try out different algorithms. Every algorithm has its own parameters, and every algorithm has its own advantages. You never know in advance what is the best algorithm. So it can be a complicated activity. For example, these days, forecasts are being generated through deep learning. Much reliable forecasts are being generated through deep learning. Many times better than the ARIMA models. So if I am using LSTM or recurrent neural networks to generate the forecast, so their performance is much better than the ARIMA models. So you might need to try out at least 3 to 4 different algorithms, at least, before you can say that this is the way I want to forecast the oil price or the stock price. And the other problem here is that the random fluctuations in the data have to be catered for, even in time series. Time series has a wrangling component because in time series, if you have missing values in the time series, the way to cater for them is different from the normal data. And then you need to remove the noise from the data. So there are ways to detect the noise, and there are several patterns that can occur in the data. So you can see all those things before you start to forecast. So the wrangling techniques for time series data are different as compared to the wrangling techniques for the normal customer data that we have in our databases. So we are going to be touching both of them, but it's a bit complicated in the time series case. So some of you might not just understand what is happening, but I will still push it. so that you know, at least you get an idea of the wrangling activity for time series, because most of our problems are time series based. Like for example, inventory, I can forecast the inventory with respect to time if I have a good model. So you can say how can you ignore sales to forecast the inventory? You need sales, you need manufacturing data, you need delivery data, but I can do away with that. Maybe the inventory has a pattern with respect to time, like GDP and all those things. Maybe for a particular store, if I can detect a pattern with respect to time, which is quite probable, then I don't need sales data and other things. I need to have better statistical models. So it is possible that I can get a very good forecast for the inventory through deep learning models. So I can do away with the customer data. I can just use the time series data to make the forecast. It is possible. So you never know how things are going to work out in data science or big data analytics. Big data analytics is basically doing all these things on big data. So wrangling on big data, machine learning on big data, making forecasts on big data, so all those things. So just need to realize that in big data, the technologies are different. So small data, I can work on Oracle and Excel and all those things. But in big data, I have to work on data lakes. And I have to work on a different type of database like Hadoop or MongoDB or let's say Redis, Aerospike, Cassandra, CouchDB, Aerospike, and there are many names now. इनमें से कौन सा बेहतर है? It depends on your need, frankly. Some of them are very complicated to configure. MongoDB is pretty easy to configure. And it's a database. That's the best part. It has a query language. So you can query that. It's very similar to SQL. Similarly, CouchDB is also something which is very close to MongoDB. That is also configurable. Redis is something which is very, very fast, lightning fast. And it stores the data in the form of key value pairs. And Hadoop is something which is more consistent. So the data lake that we're talking about is basically built over Hadoop. So you store your data in Hadoop. We're gonna see later on what's Hadoop and how to deal with that. Yeah. Yeah. The whole point is, can you pick up the pattern? Like COVID has probably a pattern which exists over 100 years. It's a cycle. It's called a cycle with respect to time. It's called a cycle. So after every 100 years, there's going to be something like COVID. That's a pattern. So if I'm able to detect that pattern in history, then I can make a prediction. Similarly, stock prices go up and down due to the governmental decisions, the decisions of regulatory bodies. If there's a pattern to those decisions, if they're not just random, it's 100% sure they're not random fluctuations. If we have random fluctuations, then we can't make a prediction. How can you predict randomness? You can't do that, right? I can make a prediction about the movement of the earth because God is making the earth move in the same way since thousands of years. I can easily predict at this time tomorrow the earth will be at this point. It's going to happen because God does everything with a discipline. But what if someone has gone mad? Some human has gone mad, for example. You can never predict what he can either kill someone or start laughing or start jumping. So you can't predict randomness. But in the decisions of those regulatory bodies and weather, for example, weather. So if there's a pattern, then you will be able to make it with some good accuracy. So these are called external variables or exogenous variables. So the mathematical modeling that you do is supposed to cater for these external variables. It's a hidden entity which is influencing, but we have to find out the pattern. So now, right now, the LSTM algorithm has got very, very good results on stock forecasting as compared to ARIMA models. Yeah, so one thing I will say is that when you talk of seasonal ARIMA model, that's much better than the traditional, because that caters for seasonality. So if your data is seasonal, so seasonal ARIMA is better for you. But it's not easy to configure. It has 6 parameters that you want to determine. So you need to learn. So you need to apply different things and understand what is better for you and what is not. You can't say in advance. Yeah? So BDA crux is that you must have a business problem to solve. Otherwise, there is no need of doing any type of analytics. You must have the business knowledge. So if you are a data scientist, for example, Benish is someone who has the business knowledge already. But if someone is a data scientist or someone from the IT department wants to solve a business problem, then they need to get the knowledge. Without the knowledge of how the business is run, you don't even look at the data. You will not understand anything. And if you have the knowledge of the business beforehand, then you will understand the data yourself in most of the attributes. You will see the data and you will say that this table does this table does this, if you have the business knowledge. Otherwise, you're just going to be teasing the IT department again and again. Tell me this, tell me this, tell me this. You don't have the business problem. For example, you want to solve the problem of customer churn in telecom. Telecom make customers churn out. For example, Mobilink customers go to Jazz, go to Ufone goes to Warid. This kind of thing keeps on happening all the time. So that's a loss, right? I lose my customer. So for example, if I am buying a supercard per month, that is 600 rupees. So 600 rupees, I shift to Warid. So 600 into 12 is 72,000 or 7,200. 7,200 rupees per customer. They lose. And what if there are 100 customers? So 72,000 rupees they lose. And maybe there are thousands of them. So they lose data in millions. They lose the money in millions due to churn. It's not easy. So to solve the problem of churn, first I have to understand what's churn. Why do people churn out? What is churn? What types of churns are there? What is the tendency to churn? What are the reasons for that? What people have done to cater for churn? We know about this old adage, history repeats itself. So just look at what others have done. You will find thousands, maybe many case studies online on how people have catered for churn, and you can just read those 5 to 10 case studies, and you will yourself develop the idea in your mind. If someone has published that we have catered for churn, so just read what they have done. So, but if you're overconfident and you start looking at the data yourself without getting the knowledge, without looking at what others have done, then that's not the right way to start. So these kind of things are not happening. That's the problem in Pakistan, for example. People do not care about background knowledge. For example, once we did a project with K Electric, I was part of some company, and the problem was to actually predict the defaulters. And I was not directly involved, but the company was involved in this project. So the focus was too much on the data from our side. We did not focus on the background knowledge of the stuff. We're still able to get very good accuracy up to 70%. But if we had gotten the knowledge, then we would probably have developed a better methodology. So that's why I've written here, you must have business knowledge. Okay. When I give you the data for wrangling, your first job is to get the business knowledge. I'll give you the template for that. Analytics team can be either in-house or outsourced. It's up to you. Okay. BI you should be knowing. If you want to do BDA, then you must be knowing BI. Power BI, what can you get from Power BI? What can you get from Tableau? What type of analysis comes in BI? So there's a whole world of analytics. It's very charming. And you need to know about Hadoop. Hadoop is basically right now you can consider it's a database for big data. Because one PC does not solve your problem of big data. So you need to solve the problem over multiple PCs, which is called a cluster. So Hadoop forms a cluster. So that's what Hadoop does. So there's, we'll talk about Hadoop later on. Okay. Cloud computing, all of you must be knowing about this. Cloud computing. What is cloud computing? You have heard the name of AWS, right? Azure AWS. क्या करता है cloud?
Store things on internet.
Store things on internet. That's a definition. That's a good definition. What else?
सर वर्चुअल मशीन्स बनाते हैं क्लाउड पे.
So Fazal Abbas, Sayyid Fazal
AWS के
Abbas is
जरिए
saying that we form virtual
Azure के जरिए.
हाँ, but cloud होता क्या है? कर गया. So cloud means PC for rent. जैसे rent a car है ना तो rent a PC. Infrastructure as a service, platform as a service, data analytics as a service, everything as a service. So cloud वाले अब आपको सब चीजें मैटर करें. यानी आपको अपना data center, you don't need to form your own data center. Everything is on the cloud if you want to use it. There are databases on the cloud. There are big databases on the cloud. There is Hadoop on the cloud. If you want to use GPUs, they are on the cloud. There are data lakes on the cloud. There are machine learning platforms on the cloud. Everything is there. So you don't need to hire, you don't need to buy any PC, you don't need to buy anything else. Just get the data science team on board and put the data on the cloud and analyze that using their own tools. Obviously, there's a problem of security and all those things, so people are not going for that. But cloud, they are giving you everything that you can do with your data. There are IoT platforms on the cloud, even IoT analytics. You can analyze IoT data in real time on the cloud. You can analyze any real-time data on the cloud using Amazon and Azure. Any real-time data. Amazon has a solution called Kinesis. Kinesis is just a real-time monitoring and processing solution. So this is how we can use the cloud. So it's not very expensive if you're taking a yearly subscription. If you decide to use the cloud for 5 years, then it's very cheap. Yeah, GPUs are expensive. GPUs are expensive, but the normal PCs are not expensive. But I mean, you use the cloud just for analytics. Because configuring Hadoop is a headache. If I have big data, I do need Hadoop. Making Hadoop cluster is a big headache. You don't find people here in Pakistan who can give you Hadoop clusters, configured Hadoop clusters, because it requires knowledge of Linux and lots of algorithmic skill set. You need to have good programmers and people who know Linux to get into Hadoop and develop all those pipelines. So you go for cloud pay, you get the clusters, just they are already there. You just need someone to put the data on the Hadoop cluster and do the analytics. That's the thing, okay? Business intelligence, what is that? So your business problem always have some KPIs. All of you know what's that, right? And you want to analyze those KPIs by using different interactive charts. And the way BI works is that these charts always give you some useful information which you don't know already. You can consider BI as part of data wrangling stage, although BI is more sophisticated, because data wrangling is like we are like washing something. BI is very sophisticated. But as compared to machine learning, you can put BI in the wrangling stage, because I can draw some BI charts also in Python. And almost all the important BI charts are also now available in Excel. Excel is not a database. If you are storing your data in company in Excel, you don't have a database. You are in trouble. Excel is not a database. But with the power user add-on of Excel, I have access to almost all the standard charts. Like the new charts are the macro chart, for example, and the macro chart. This I forgot the name. Sankey chart, macro chart, waterfall chart. All of these are relatively new, not very new. So all of these charts are now available in Excel. You just have to put the power user add-on and the charts. So that's why I'm saying Excel is a wrangling thing for me. For me, Excel is wrangling. If I'm able to put BI charts in Excel, then BI becomes part of wrangling. Excel is not a database. So BI you are analyzing the KPIs across dimensions. So your data is divided into KPIs and dimensions. Dimensions are things like customer, product, location, time. Okay, across the variables, across whom you typically analyze the data. For example, if Venus wants to analyze sales, she will not say what are the total sales, but she will ask the total sales with respect to some location or some store at a particular time for a given customer category for a given product. So you have these, you can say crossing points over which you analyze the data. These are called dimensions. So a BI tool is always going to divide your data into KPIs and dimensions. That's it. Uska aur koi nazariya hai hi nahi. You analyze the KPIs across multiple dimensions. Okay. So the more important जो tools हैं BI के, उसमें Power BI is very famous. Click का एक tool है Click Sense. ये cloud पर भी available है. ये मैंने पिछले semester I have taught the BI course to undergrad students, and I have used Click Sense for the first time through an academic license, and it's absolutely wonderful. There's so much you can do, and so much you can extract from those charts. It helps you get the information which you can't even think about. Click Sense. Click is the company, right? Click, QLIK. ClickView is the old tool. Click Sense, I think, is their new analytics tool. When you study the BI course, so you will have to go through all these softwares. I don't know the teacher whether he will do, but definitely I think he will do Power BI. Yeah. Just learn one tool in this course, and then you can try out everything. There are so many tools. We can't teach you everything here, right? नहीं, मैं ये नहीं कहूँगा. The Tableau, Power BI, ClickView are three giants. Tableau में the visualization impact is tremendous. Power BI में diversity is tremendous, and Click is I think both things are tremendous. ClickSense is, once you start using that, you don't want to go anywhere else, really. So all these three are giants. Okay, so the main thing in BI is the charts. The charts help you get the information, but you must know how to use the charts. That's the thing. So these are very simple charts like donut charts and bar charts, line charts, area charts. But all of these, one dashboard gives you one message. So at the back end, you can have small data or you can have big data. It does not matter. You can analyze 500 gigabytes of data to make such a chart, or you can analyze 50 megabytes of data to make such a chart. It's up to you. But when you do BI over big data, then at the background, you need to have big databases. You can't do that using Oracle. Oracle se nahi kar sakte. You have to bring your data into some repository. There's a lake. A lake is a complicated thing. But if you don't have a lake, then you have to bring your data to somewhere else. And then you have to store that data in a big database. And then you analyze that. Like Hadoop ke upar store kar lein, MongoDB mein store kar lein, then it becomes easy. Otherwise, you can't make such a chart on big data. It's impossible because compiling such a dashboard also requires a lot of RAM. There's a lot of figures here. The more heavy the dashboard, the difficult it is going to come. It's going to take more time to compile because these charts get updated themselves. So imagine that big data is coming again, continuously coming, and this chart has to be updated after every 6 hours. It could take a lot of time if you don't have enough memory. That's why you need Hadoop. Okay. So now I'll just go through this very quickly. So in this case, 1960s was the time of garage computers. I've already told you. And at that time, there is one algorithm of machine learning, which is called a neural network. So that was introduced, and that basically led to a lot of expectation about robots and what other things. But it was difficult to train that algorithm. So it died out for several years. 1970s, I've told you already, it was semiconductor, like we have the motherboard right now. Every PC has a motherboard inside it, which is the main brain. And we have the CPU, and all of these are now based on the semiconductor technology. That is getting smaller and smaller using nanotechnology. So 1970s, you came up with this relational model, the database model, relational model, and also SQL. 1980s, we saw this as SQL Server was launched by Microsoft in 1986 or 7. And IBM launched DB2, but Oracle was launched first. And then this predictive analytics came in 1980s. But in all of these times, 60s, 70s, 80s, people were doing statistical analysis, either on paper or through softwares. Statistics was there since a long time. But when the databases came, then people wanted to use them for making predictions. So they started to now use statistics for making predictions. Then the 1990s, we have the internet, and MySQL and Postgres are two open source databases. MySQL is now owned by Oracle. Postgres is still independent. Okay. And 1990s also saw the BI tools. So I think Power BI was not launched in 1990s. I think the first BI tool was, I forget the name. Maybe it was OBI by Oracle, or maybe it was something else. In any case, the concept of business intelligence was formalized in 1990s. And the tools, this Tableau and Power BI, they came around the same time. Now we have also other tools like SciSense. SciSense is another BI tool. And there are many others as well. Okay. So BI tools and data warehousing. Data warehousing is exactly that. How do you analyze the KPIs over dimensions? That is data warehousing. So basically, you are doing data warehousing through BI tools now. So all those charts are helping you to do data warehousing. I mean, analyzing the KPIs across different dimensions. Okay. Yeah, I'm going to give you an exam right now today after reaching home, which you are going to solve by next Sunday. Isn't that good? No, I'm serious because they're going to be just logical questions over what I've explained. Because if you don't write, if you don't learn, then for me that is just listening is not enough. 2000 to 2005 is, or this LinkedIn, Facebook, Google, GFS and MapReduce are basically Hadoop. Okay. Twitter, Hadoop, MongoDB, NVIDIA is what the company which makes the GPUs. GPU is basically thousands of CPUs together. So it makes deep learning very easy. or image processing very easy, or image designing like simulations, big simulations, very easy. Azure, Amazon was launched in 2007, I think. Amazon AWS, Amazon Web Services. NoSQL basically means big databases. Like talking about MongoDB, Hadoop, and Spark. Redis. I told you the names of several databases, which are big databases. So they are called NoSQL databases. Okay. And then after that, we had a plethora of inventions like deep learning, predictive analytics, Azure cloud platform, data governance, BDA. So ever since the last 10, 15 years, so they are occurring. So that's the backdrop. We have already talked about this, that data is growing rapidly. Okay, so there is no doubt about it. Okay, every company, the data is now increasing. And you need, if you are the right person, you will want to use that data to analyze. If you're not, if your company is making a good profit, you will not feel obliged to do that. आप कहेंगे जो चल रहा है वो चलने दो. Absolutely, that's the way. That's the way. But now there are open-minded people in higher management, because when these guys visit abroad and go to research seminars and other talks abroad, they go for trainings. So then they realize what's happening there. And if the company can afford it, then they do implement it. Gee. Restaurant. Yeah, that's, in fact, that's something which is pretty useful for the cities, because you don't want to go to the same place every time you go out. So not to this extent, but going out, yes, like eating out places, because the reason is that different types of eat outs are springing up from time to time, and you don't even know about them. You just see them and go. So online, yes, there needs to be a system of, give it the preferences, tell you just go there. It's something which is in your price range, and so there's no such system currently. It recommends you food, but it does not recommend restaurants. So there's a need for such a startup which does this. In Karachi, you can become a millionaire within 1 week, because Karachi people are earning lots of money, so they want to now spend the money to go out and eat with families and with cousins, for example, or relatives, whatever. So you need recommendations, yeah. So if your predictions are good, then the people will start using it. So the problem is that making the predictions always according to the people is not easy. Yeah, but it's not just about the price. It's about the wish of the user at that time. It's not about the price of the restaurant only. What the user wants at that time, that's more important. How many people are with him? Are you going stealthily, or are you going with a family? So some people want to hide that they are going with someone. गुनाह में तो यही होता है ना. आजकल तो फैमिली के साथ जाना भी जो है मुसीबत बन गया है रेस्टोरेंट्स के अंदर. So yeah, so we are all, what is KYC? Know your customer, so your data is not being used to its full potential. Okay. And all of these reasons, the data is now increasing, and most of you will agree with me. So volume is increasing, velocity is increasing, different variety of data, veracity. It's getting difficult to maintain the quality of the data. Value of the data, that's what you want to derive. Vagueness. If you don't have governance, you're going to have vagueness. Okay, one concept is going to be represented through different names, like customer name. So someone can write in one table C name, someone can write CST name, someone can write cust name, someone can write CN. It's gonna same thing. You need homogeneity, right? So governance is going to solve the problems. Vocabulary. Vocabulary comes from background knowledge. Like in the case of supply chain, we have GMROI, a very important gross margin return on investment. It's a variable, but I mean, what does that mean? I don't know. I'm not coming from that background. I don't even know how to calculate ROI. It must be having some formula, right? So the domain people are going to tell you. Venue means where the data is stored. The data can be stored in multiple places, cloud as well as in-house. Variability, the data evolves. That's a huge problem. You learn the model over a fixed, आपने data इकट्ठा किया, you use that to forecast the stock. Then the data pattern changes. The pattern changes, the model fails. You have to learn the model again. You have to adapt the model. So the example is that you have 500 e-commerce customers. You want to make a prediction about what to show them. You take their data for 500 customers and you spend five weeks or 6 weeks and you say, hey, I got the algorithm. You go out and put the algorithm in the server, starts recommending and everything is good. But suddenly the customers, something happens and the customers change their behavior. COVID comes, or some sort of recession comes in some particular sector, and 200 of your customers suddenly change their buying behavior. Your model fails. So now you need to adapt your model to those customers. It's not a one-time activity. That's why you need a BI team. And then validity, again, it's the same as veracity, data accuracy, quality. So the major problems listed here can be solved through data wrangling. That's the message. So you must, in this course, you must develop the skill to wrangle the data. COVID is an exception which occurs after many years. It's an outlier. When you have an outlier in the data, then you develop separate analytics for that. You don't merge that with the normal flow of things. Okay. If we become tuned to COVID after 1 year has passed, so COVID becomes a part of life, then the normality includes COVID. Okay, the normal life is with COVID. अब COVID के साथ ही जीना है, COVID के साथ ही मरना है. ठीक है. So, but right now the situation is not like that. We are waiting for COVID to finish, but it keeps on. It's the will of God to be. It has to be. All of us are being punished probably, or reprimanded or warned. The life has changed in the whole world. So, but as far as analysis is concerned, so now we have to do everything with respect to COVID. So COVID specific, not COVID specific, and there's no use in comparison because now COVID is a part of life. So these years, 2020, 21, 22, 23, who knows when COVID will go away. So these 4 years are outlier years. They are not the normal years because COVID introduces a lot of randomness. And that's why it's going to create problems for machine learning guys. Not for e-commerce, I think, because it's just online. Okay. So these are the different verticals. All of you are from these verticals. You can identify your verticals from here. It's not. So this was the big data landscape, I think in 2010 or 11 or something like that, 2012. So the solutions for managing big data that were being offered at that time were categorized in these boxes: vertical apps, ad, with BI tools. You can see ClickView is there again, but you don't see any Power BI here. Rather, you see Oracle, you see business objects from SAP, which is their BI tool, I think. Cognos from IBA कह रहा हूँ, IBM. MicroStrategy again from IBM. And I don't know about other ones. Okay. So analytics, you got Tableau, although Tableau is now a BI tool. Palantir was one company which was very famous, but now it has gone down the drain, I think. And so there is an overlap between business intelligence analytics, because Tableau is a BI tool. So put that in BI. Why are you putting that in analytics? Probably because it also allows you to forecast the data, probably because of that. So structured databases are the ones that we already know: infrastructure as a service, operational analytics infrastructure. These are the big data companies that you should know about: Hortonworks, MapR, Cloudera, EMC. I think one of them has merged. So Hortonworks, I think, has merged with, or someone has merged with the Hortonworks. I don't know right now. So we'll see that later on. And here you have Hadoop. So Hadoop is storing your data over a cluster, but it involves many other technologies like HBase, Spark, Cassandra, Hive, Zookeeper, Apache Ambari. So there are maybe 10 to 15 different products which run over Hadoop and allow you to do anything you want to do with big data. Big data, BI over big data, warehousing over big data, machine learning with big data, everything you can do over Hadoop. But again, the problem is that configuring Hadoop is a headache. That's the main area where this thing changed after 2 to 3 years. So it became, this was version 1. This is Big Data Landscape version 2. You can see things are increasing exponentially. Okay. So you can see the slide when I give it to you tonight, in fact. So lots of things are sprung up. This is version 3. It becomes more complicated, and this is the latest one. So all of these tools are there to manage big data, or you can say maybe 80% of them are there to manage big data. This is the big data landscape. So we assume that all of these are there. So data sources, I don't know, we can't even read them now. So Hadoop on the cloud, Hadoop on premise. On premise, if you want an on premise solution, so MapR and Cloudera, Hortonworks can help you install, give you an on premise solution, but not in Pakistan. Maybe in Pakistan as well, I don't know. But in Pakistan, we have shortcuts to do many things. We don't need Hortonworks to implement a Hadoop pipeline. If you want to do it, you can do that in a cheaper way, and not Excel, but you just need to have 1 to 2 good people with you, and then you can do it. That's the thing. Let's talk about BI. I can't find BI. So machine learning is there. So the different tools are here. BI platforms, you can see. It should involve Power BI. I don't know. Maybe I can't see it now. But this is Hadoop. So what is the strength of Hadoop? Hadoop stores your data over a cluster of computers. So you don't have one computer, you have multiple computers. That's how you manage big data. Simple. But to manage that cluster is what is being done by HDFS. HDFS is the Hadoop distributed file system. It helps you manage the clusters. Obviously, if I have 10 PCs connected together in a Hadoop cluster, I have to manage that. So the backbone is HDFS. Just remember that, HDFS. Okay. Management is one thing, but I want Hadoop to do my work. What is the work? Analyze big data. For what? For BI, for machine learning, for whatever. So Hadoop uses Yarn to do the management of any task. That's called processing. Processing. Okay. Process means to work, like doing analytics. Storage is not processing. आप data store कर दिया, वो काम थोड़ी है. Process is the work that you want to do. Okay. So storage is being managed by HDFS and coordination between the clusters, because if you give it one task, it is going to be executed in parallel over different PCs, because that's how you manage big data. So for that, you need another software over Hadoop, which is called Yarn, that does the cluster resource management. So I give you, okay, this is 500 gigabytes of data. I put that in make the box plot from this data. So that can be made, but for that I will calculate the box plot, parts of the box plot at different parts of the cluster. हर PC पे थोड़ा चीजें compute करके, then we are going to aggregate them and then show them on one single PC. So a task is divided into multiple tasks. Multiple tasks are executed on different PCs. The results are aggregated and shown. Divide and conquer. So for that, you need Yarn. At the backbone, you need HDFS, manage the logistics. But CALM for the processing, then you need Yarn. Okay, and you do the work through MapReduce. There are two technologies which you can use to do the work over Hadoop. Any big data task that you have, you can do that either using MapReduce or using Apache Spark. Apache Spark should be here. It's not here, but you can write that down. Either you use MapReduce or you use Apache Spark. So very quickly you can do anything over Hadoop that you want. Big data. So the big data solution is now there, that if you want to use Hadoop, you can use Hadoop, install Hadoop over different PCs. HDFS will join them. And if you want it to work, then use Spark, because MapReduce is slow. Spark is very fast. Spark uses your RAM. Understand? And other things you can use over Hadoop. If you want to store the data over Hadoop in a database, that is HBase. If you want to import the data from any other database written in, for example, you have written your data, you have written your analytics pipeline in Python, someone has written in Scala, but you want Hadoop to understand everything. So you can use Thrift for that. You know, while importing the data, if someone, for example, you are giving me data, but you are sending me the data through a Python script, and you are sending me through an R script or JavaScript. So Thrift will be able to understand both of them, get the data from you and put it in. Avro is a unique format. So I will say that if the data wants to come in Hadoop, then put that in Avro format, which is JSON. Avro is quite famous. Drill, Apache Drill. I can run SQL over Hadoop. Although Hadoop पे जो data store हो रहा है, Hadoop is not using tables, not at all. Hadoop is storing simply in files. It's making its own files. It's not a table. But Drill is going to create a table over the Hadoop data, and I can query that using SQL. And Hive is also something which is extremely important. Hive is the formal database over Hadoop. I can create tables over Hadoop like I create tables in Oracle. Hive is a very, very important add-on to Hadoop and is almost always used. Hive, Apache Hive is almost used with the Hive, because the data that is there, files are nothing to me. I need the tables. So I can create the tables permanently by using Hive. And I can then query those tables using Apache Drill. So the problem is solved. I don't need to move away from SQL at all. Because when I'm changing the database, I'm changing the query language. But Hadoop, I don't need to change the query language. The same database, but big data. Now I can use SQL to query that, because I have Hadoop, I have Hive, I have Drill. Or Drill ke alawa, I also have Presto. I can either use Drill or Presto. But I think Drill is better in some respect. So imagine these are the big data solutions. And Mahout is machine learning over big data. आप तो Python पे script चलाएंगे, machine learning कर लेंगे. That is small data. Big data machine learning means that you do machine learning over a cluster. That's difficult. You can use that either using Mahout or using Apache Spark's machine learning library. But you can do prediction on big data. Yarn, when you give something to do to Hadoop, Yarn manages the resources like RAM and hard disk space required. Yeah, this is going to manage the task the work that you give it is being managed by this. The hardware level coordination between the PCs is being managed by SDFS. Yarn runs over SDFS. SDFS is the backbone. But Yarn is only for the tasks. When you give it some tasks, then Yarn is going to come into picture. Otherwise, Hadoop is silent. Yarn is sleeping. That's the thing. Okay. Pig is a language for writing MapReduce programs. If you want to use MapReduce, then you can use Pig to write the MapReduce code. But you can also use Java. You can use Python. Typically, we use Python. We don't use Pig. And Uzi is a workflow. Scoop means to get the data from the database. So Oracle se data lana hai, Hadoop mein you use Scoop. So this is a very strong ecosystem which can solve the big data problems of any company in the world. But the problem is that you need the skill set. You need someone to maintain. Like for the IT department, they are hiring people to maintain the Oracle databases. It's not easy. It's a very difficult task to maintain a database. Easier said than done. So if you are able to get 2 to 3 people to do this, then with peanuts, you can solve the big data problem. All of these are open source. Just peanuts. You just have to pay 2 people. You need the right mindset. So this is the final slide. We have already talked about this. All of these are problems which are there. Missing values, incomplete data, faulty data errors, unnecessary columns, unnecessary rows, duplicated data, as Dinesh told us. Change the data types, rename the columns, blah, 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 blah. So now your task is that today I'm going to give you this presentation. So I'm just going to stop recording.